This is section 7.2 in our textbook on multiplying and dividing rational expressions. So we're going to start talking about multiplying. There are 3 steps, pretty simple. The first step is to GCF and factor. So look for GCFs and factor anything you can, top, bottom, either expression. So GCF and factor anything you can. The second step is to divide out. Again, anything you can. So the longest part is the GCF and the factor. You just go through the problem looking at the top and the bottom of each expression and try to GCF or factor whatever you can. After you've got everything factored out, then you can divide out anything that you can. And then the third step's the easy step. You multiply whatever's left. And when we multiply fractions, remember it's top times top and bottom times bottom. So we'll just run through a few examples here until you get the hang of it. So example 1, if we have negative 7x squared over 5y times 3y to the 5th over 14x squared. So there's single terms, top and bottom, single term, single term, single term, and single term. So there's nothing to GCF and there's nothing to factor because there's just single terms. But we can divide out some things. We have a 7 and a 14, and they both divide by 7, and that can reduce. We have an x squared and an x squared, top and bottom. Those can divide off, so I can cross those out. Then we have y to the 5th and y to the 1st. So the 7 will become a 1, still negative. The 14 will become a 2. So this gets a little messy, but you can just kind of cross things out that divide out, reduce any values on the top and the bottom that you can, and then you have whatever's left. Negative 3y to the 5th from doing negative 1 times 3y to the 5th over 5y to the 1st. Then we can use the quotient rule. 2 times 5, I missed that 2. So it's going to be negative 3y to the 5th over 10y to the 1st. Now you can use the quotient rule and you'll have negative 3y to the 4th over 10. It's the y to the 5th and y to the 1st. One of them divides off. So be careful. You'll notice I missed a reduction, so just be careful when you're working them out. Alright, let's try another one. Example 2. If we have negative 3p to the 4th over q squared times 2q to the 3rd over 9p to the 4th. And if you'd like to pause the video and try this one, you're more than welcome to. Here we've got a 3 and a 9. That's going to become a 1, still negative. That's going to become a 3. We've got p to the 4th and p to the 4th. Those divide off. Then I'm going to put what I have left together. Negative 1 times 2q to the 3rd is negative 2q to the 3rd. And q squared times 3 would be 3q squared. Q to the 3rd over q squared would leave 1q on top over 3. So we're just simplifying this through multiplication and reducing as much as we can. Alright, so those are just single terms, not too bad. Let's look at a couple with binomials. So example 3. If I have x squared plus x over 3x times 6 over 5x plus 5. Now this looks big, scary, and crazy and too much going on. It really helps if you take a different color pen or pencil, and anytime you have more than one term on a numerator or denominator, put parentheses around it. Kind of makes it easier to look at. If I just look at the top of the first expression, I have x squared plus x. I should be able to see a GCF of x, and that leaves me with x plus 1. So just the top of the first one can be simplified by taking out a GCF. The bottom of the first one we can't do anything, so I'm just going to leave it 3x times 6 is just 6. Between 5x plus 5, we can take out a GCF of 5, and then we're also left with x plus 1. So again, I just took out a GCF. Then you just kind of have to see what you have left over. Here's an x on top and an x on the bottom. Notice they're both outside parentheses, so I can cross those out. I have a 6 and a 3. They can both divide by 3. The 6 can become a 2 and the 3 can become a 1. If you're not too comfortable doing that, there's another way to get the answer at the end. But I like to kind of look diagonally and see if there's anything I can reduce or cross out. Here we have an x plus 1 on top, x plus 1 on bottom, and divide those out. And we're left with 2 over 5. Let me make sure here. X is crossed out. Yep, that's nice and simple, 2 over 5. So sometimes it can really reduce down just depending on what you have. Let's try another one. Example 4. X squared minus x over 5x times 15 over x squared minus 1. If you'd like to try this one on your own, you can, or you can watch me. Pause the video if you'd like. Anytime I have more than one term, I'm going to lock it up with parentheses to help me focus. If I look at x squared minus x, I can take out a GCF of x and be left with x minus 1. The bottom stays 5x times 15 over, now x squared minus 1 is a difference of squares. It's hard to catch, but anytime you have a squared term, look for that difference of squares. So that actually factors into two binomials, x plus 1 and x minus 1. So again, then we just kind of scan it, see what we've got. We've got an x on the outside here and an x on the outside there. Those can divide off. We've got a 15 and a 5, so they can both divide by 5. And we've got an x minus 1 up top and an x minus 1 on the bottom, so they can divide off as well. And it looks like we're left with 3 over x plus 1, because that 1 won't change anything. So again, we're taking something kind of crazy looking, taking out GCFs, factoring, dividing off whatever we can, and we end up with something that's not so bad. Alright, let's look at a couple more. These are going to have trinomials in them. So example 5. We have 3x plus 3 over 5x squared minus 5x times 2x squared plus x minus 3 over 4x squared minus 9. Again, a lot to look at. I suggest taking it one piece at a time. We've got a binomial on the top. Notice it's linear, it's just an x and a constant. We have a binomial on the bottom, and it's got an x squared and an x. Just kind of look at what you have. We have a trinomial on the top with an x squared, an x, and a constant. This one's going to require factoring. And then we've got a binomial on the bottom with x squared and a constant. So one thing at a time. If I look at the top of the first term, I see a GCF of 3. That leaves me with x plus 1. Just that one piece. If I look at the bottom of the first one, 5x squared minus 5x, I can take out a 5x. That leaves me with x minus 1. One thing at a time. Now the top of the second one is going to factor into two back-to-back binomials. Notice the leading coefficient is not 1. So we're going to have to set up a little chart. And I recommend working that kind of off to the side of your problem on your scratch paper so it doesn't get mixed into your problem. Make your table. It's -6 and 1. Be 3 and -2. So split your middle term. Factor by grouping, so take your time on this. You don't want to mess this part up. If you want to pause the video and work it out, that's fine. But off to the side, away from your problem, you want to go through your factoring process and get your final factored form, which is going to be x minus 1 times 2x minus 3. So take your time on that part. You don't have to do that in your head. Then the bottom of the second one, 4x squared minus 9. Notice that it's x squared, it's subtraction, and 4 and 9 are perfect squares. So this is a difference of squares. Anytime you have a squared term, see if it can be factored. So it's going to factor into 2x and 2x from the 4x squared, 3 and 3 from the 9, and 1 gets a plus and 1 gets a minus. So watch for that difference of squares. From here, my favorite part, we get to cross stuff out. So let's see. We have an x minus 1 on the bottom here, and an x minus 1 on the top there. Gone. We have a 2x minus 3 on top, 2x minus 3 on the bottom. Gone. What else? I think that's it. So we're left with 3 times x plus 1 on top. There's no need to distribute it in, it's just leave it. On the bottom we have the 5x, and then we have over here the 2x plus 3. And I know that doesn't really look like an answer, but you're just going to stop there. Remember, we're not trying to solve these, we're just trying to simplify them. Alright, I'm going to put one more up here for you to try. Just pause the video, try it on your own first, and then see how you do. This is example 6. And then I'll make a separate video for dividing. So 3x minus 6 divided by 6x squared plus 6x, that's one rational expression, times 3x squared minus 2x minus 5 over x squared minus 4. So I recommend pausing the video right now, working out as much as you can. Just take your time, work out whatever you need to, show your steps if you need to, then play the video to watch my solution. Alright, so I'm just going to look at the top of the first one, do what I can. Bottom of the first one, do what I can. Top of the second one, do what I can. Bottom of the second one, do what I can. And I'm going to write it down here. So we're going to have that same setup. Something, 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 something. 4 parts, ready to go. So if I have 3x minus 6, I can take out a GCF of 3, and I'm left with x minus 2. The bottom of the first one, 6x squared plus 6x. Take out a 6x, I'm left with x plus 1. Top of the second one requires factoring, a, b, c. I'm going to make my little table off to the side. -15 and -2, -5 and 3. Split my middle term. You don't have to do this quickly, but you should be efficient at this. Then grouping. You should get x plus 1 times 3x minus 5 on the top. The bottom is a difference of squares. Those are sneaky. Always look for those difference of squares, and it factors into x plus 2, x minus 2. So get everything GCF'd, everything factored out, whatever you can do. Show whatever side work you need to off to the side. Then I always like to get a different color and cross stuff out. Let's see. 3 and 6 divide. The 3 becomes a 1, the 6 becomes a 2. X minus 2 on top, x minus 2 on the bottom. Cross those out. X plus 1 on top, x plus 1 on the bottom. Don't go too crazy with your crossing out. you should have 3x minus 5, and you can leave it in parentheses. I like to leave it in parentheses, over this 2 and this x, don't forget about the x, 2x times, the only other thing left down there is x plus 2. So again, your expressions look kind of crazy, but that is your answer. So that's multiplying rational expressions, and dividing is very similar. I'll make a separate video for that.